This video is going to be on this method called synthetic division, which is used for dividing polynomials. In previous videos, we've talked about dividing them with greatest common factors or factoring it out, as well as using long division, and synthetic division is kind of like a shortcut. It works the same as long division, but without doing a lot of the writing. The only problem is that it works best if a certain condition is being followed. And that certain condition is that what you are dividing by is a linear expression. Meaning, we want something like this as our divisor, and not something like this. Okay, we don't want that. This also works best if the coefficient on x is 1. Oh, that's a terrible one. Is 1. Could we do it if this wasn't a 1? Yes, it's very possible. It just makes it a little more complicated. And so for the purpose of this video, we're going to be dealing with just linear expressions that have a coefficient of 1 on the variable. So with that said, let's get to our first example and see how synthetic division works. Alright, for our first example, we are going to divide x squared plus 5x plus 6 by the quantity x minus 1. And we have in our denominator a linear expression with a coefficient of 1, so we're following what I said would make it easiest. And to start off with, we are going to draw what looks like an upside down division bracket. So I'm going to draw it right over here. On the inside, we're going to take the coefficients here. And it's very important that we go in order. So x squared to 1x to no x's. If any of those are missing, we have to fill them in. So we'll see that in a future example. But for right now, everything works out. So just take your coefficients. So I'll start off with 1, and then 5, and then 6. Now, just like with long division, we got to have something on the outside. And what's going to go on the outside is the number that makes this denominator equal to 0. So I have x minus 1. What do I put in here to make this 0? Well, that would be 1. So on the outside, we're just going to put 1, because 1 minus 1 is 0. Another way to think of it, if it looks just like this, flip the sign on the constant. Since the constant is a negative 1, we use a positive 1. Now for the synthetic division. We start off by just dropping down the first number. Whatever it is, we drop it down. Now, we take the first number and we multiply it by the number on the outside. 1 times 1 is 1. So we bring it up here as this, and then we add them together. So what's 5 plus 1? It's 6. Now, just like before, we multiply the 6 by the 1 on the outside, and 1 times 6 is 6, so we bring it up in here, and then we add these together. 6 plus 6 gives me 12. And believe it or not, we're basically done. Okay, so here is where I'm going to create my answer from. Since we had 3 numbers, our answers is only going to have 2 numbers. I'm going to draw a little box around this 12 because technically the 12 is our remainder. And what do we have? We have x plus 6, and I'll put a 1 in front. So think of the first number outside of the box as the constant, the next number as our x term, so that's why I put an x with it. If there was another one, we'd have to have an x squared over here and so forth. You'll see that later on. And for the remainder, because we don't want to forget about that, we just add the 12 over what the original denominator was, so x plus 1, because it did not divide out evenly. And this is our final answer for this synthetic division. A lot less work, a lot less writing, and it's very formulaic. So if you like stuff that there's a process that you can follow and memorize, this is the process for you. The only downside is you can't use it for everything. So here we go. That is our answer. Let's try it with another problem. In our second example for synthetic division, we have x cubed minus 2x squared plus 3x minus 4, all divided by the quantity x minus 2. Notice that in this example, we have more terms up top. So when we create our little upside down bracket, we're going to have 4 terms to populate it with on the inside as opposed to just 3. And our final answer is going to be consisting of 3 terms and possibly a remainder. So let's put our box together. We've got a coefficient of 1, a coefficient of negative 2, a coefficient of positive 3, and a coefficient of negative 4. And our denominator is x minus 2, so what's going to make this 0? It's positive 2, so we'll put a positive 2 on the outside. Now, drop down the first term, and then we multiply by the term on the outside. So 2 times 1 is 2. Add these terms together. Negative 2 plus 2 is 0. So I get a 0 down here. Multiply 0 times 2 is 0. So we're going to have a 0 on the inside. And I didn't draw my arrows showing things going that way, sorry. 3 plus 0 is 3. And then finally multiply the 3 and the 2 so that we get 6. And then add negative 4 plus 6, which gives us negative 2. Just like before, this last term is going to be our remainder. And we can start on either end, but if you're just getting used to this, remember the number that is right next to the remainder is our constant, so we're going to have 3 plus, I have a 0 here, and normally we don't care about the 0, but just for continuity's sake, we're going to have a 0x plus a 1x squared. And then we have our remainder, which is plus negative 2 over the original denominator, which is x minus 2. And we can simplify this down so that we get rid of that 0x, since it doesn't need to be there. And we end up with a final answer of x squared plus 3 plus negative 2 over x minus 2. Hopefully you're seeing how this process works, not finding it to be terribly difficult, and maybe even enjoying it. It takes a lot of the paperwork out of this because you don't have to write down as much. It's pretty nice. Alright, our final example is coming up next. Alright, for our final example, we have the quantity x squared minus 9 being divided by the quantity of x plus 3. Now, just because I wrote it with the actual division symbol instead of writing it as a fraction does not mean anything has changed. We can still do this with synthetic division since the coefficient on x is 1 and this is a linear expression. So, the only thing that's different, hopefully, is you're noticing, oh, I go from x squared to a constant. I'm missing a term here. I'm missing that x term, so I'm going to have to account for it in my upside down radical. So when I fill this in, I'll have 1 for the x squared, I'll have negative 9 for the constant, but for the x term, I have to include a 0. Okay? And you always have to include those zeros, otherwise this will not work out properly. So, now, what is going to make this 0? That's negative 3. And we can begin. Drop down your 1. 1 times negative 3 is going to give me negative 3. Add these together. 0 plus negative 3 is negative 3. And then multiply negative 3 times negative 3, which is positive 9. And negative 9 plus positive 9 gives me 0. So what we see here for the first time in these examples is my remainder is 0. This divided out evenly. So I'm not going to have any kind of a remainder, but my final answer is going to be what? Hopefully you say to yourself, x minus 3. Because, remember, the first term next to where the remainder would go is our constant of negative 3. And then this becomes our x term, and it has a coefficient of 1. So there you have it. There is synthetic division with several different types, including when we are missing a term in the middle. Whether you like it or not, hopefully you found this informative and will be successful with using synthetic division in the future. Good luck.